Devon, let's start first then. Okay, Jingjie cannot make it, so I'll do a recording for him. Really, he cannot make it too. Okay, hold on. I believe your kinematics is covered, right, for the test. It is. Okay. Then we'll just do a quick revision. Okay, come. You have your notes with you. Let's go. Okay, then might be go again first. Okay, tell me, what is the formula that you need to use? There's only one. Equals to
Speed minus initial speed over time difference.
Okay. Yep, very standard, but definitely coming out. Now, tell me, what are the units for acceleration?
Square.
Okay, good. Units for what? V? Good. Units for U?
So,
Okay, make sure of that. Time. Yep, so make sure your units are all correct before you use the formula. Okay. Ujin, are you there? Ujin, are you there?
Hello.
Okay, good. You should be able to see my share screen, right?
Of course, yes, I can.
But I cannot even see your face.
It's okay. It's okay. Wait.
Yeah, it's
Can?
okay. Yeah,
Okay, can.
not really. I can't see your face, but never mind. You can remain faceless.
Of course, of course, of course.
Okay, come, Diman, tell me. The other thing that's confirmed coming up will be the graph. Confirm 100%. Definitely your graph will be like this. Okay, so speed, time, graph. And then they'll ask you to describe. So let's say for this case, how do you describe this? Of course, you separate into two parts. I think it's obvious. How do you describe the first part? And constant?
Constant acceleration.
All right. Don't get confused, please. It's increasing and it's a straight line, so it's at constant acceleration. Okay, reminder, even for Fujin as well, this is constant acceleration because it is a straight line. Of course, you don't have to write that in your answer. How about the second part, Devon? A constant speed, is that acceleration? So acceleration is?
Yeah.
0. Okay, again, don't get confused. But let's continue our story. Fujin, you better follow. This surely will come up for you as well. Now, let's continue the story. All right, Fujin, now your turn. How do you describe this part?
Monkey.
Hey, come on, be serious. Your test is coming.
I don't do my test, can or not?
Oh.
Okay,
Would you?
I. What I mean describe?
How do you describe the purple part?
Deceleration.
Okay, then how do you describe the speed?
Speed is constant,
Oh,
but
constant.
it's decreasing
Yeah.
at a constant pace.
Okay. At constant, but the first point was correct, so it's at constant deceleration. All right, so make sure you can recognize acceleration versus deceleration. Diman? Okay. But maybe I just add one more point to the last portion here. All right, the speed is decreasing, yes. Now, if let's say it goes now to the x-axis, decreasing to 0. Okay, now as I said, this is a speed time graph. Speed time graph. How do you measure the acceleration? Devan? The acceleration is indicated by yeah, I know just now I asked you about the formula, but beyond the formula, if you look at the graph, the acceleration is given by the don't get confused, the acceleration is the gradient. Can, don't confuse yourself, please. All right, yeah, make sure you revise your notes. Wujin, your turn.
No, never.
She mentioned about area under the curve. What does that tell you?
Wait, this is a speed time graph, so that would be the distance.
Excellent. Okay. Ivan, you
Team
take
model
note too.
student right here, guys.
Make sure you get A1. Okay, so these are the basic things. Yeah, both of you don't mess up. These are the basics. I haven't even touched on any difficult questions yet. So, by the way, let's say for this particular example here, I'm interested in, let's say, this area. Oh, sorry, let me use another one. Okay, I'm interested in this area. Come, Divan, how do you calculate this area? Okay, good. Wujin, take note. Make sure you know your half times base and height. Okay, come, Divan, where's your base and where's your height? Okay, so let's take it as the base and where's the height? Yep. Okay, yep, basic things. I just want to make sure you are all certain of this. Now, on the other hand, let's say I'm interested in this area. Yep, Fujin, your turn.
Okay.
How are you going to calculate this area, Fujin?
You get the okay. So we have the area which is the yellow one, right? We take that height, and okay, this is a trapezium. It's sum of parallel sides times something.
Okay, you have to know better than that. Come, area equals to
half times sum of parallel sides.
Good. Times.
Height.
Yes.
Fuck. Oh shit, no cursing.
No swearing.
Yeah, that's what I said. That's what I said. My bad, G. My bad. Honest mistake.
Okay. So I hope you guys realize this is side 1, and this one will be side 2. course, the height is still the same as what Devon has done just now. Okay, Devon. Okay. All right, Fujin, you too. Remember the formula.
Okay.
Yep, that is okay. Let me see anything else to tell you. All right, so let's say I give you one more example. Let's say I give you, let's say this is 0. And this one is, let's say 10 meters per second. And the time here is 2 minutes. Okay, come guys. I want you to calculate the acceleration, this one, the constant acceleration. Yeah, do you want to try that out? Fujin, you as well? Remember, there's only one formula to use. Make sure you write down the formula in your working first.
Holy shit.
No swearing, Fujin.
I'm not.
Come, work out your acceleration, Fujin.
A equals V minus U over T.
Then what's the value? What's the answer?
What is V?
V is the final velocity.
Final velocity over initial velocity, right?
No, final minus initial over time. Huh, Devon, got it? What's your answer, Devon?
Wait, 0.83. 0.3.
Okay, fine. Fujin, make sure you get 0.083. I'll write it out in case you did not manage to figure it out. Make sure your units are correct. Okay, great. Now, one more. Let's say I told you that this time is 4 minutes. And this time here is 5 minutes. Okay, now I want you to calculate something else. Calculate the deceleration. Yep, guys, try calculating deceleration. Now you use the same formula, but there's a slight twist, so just be a bit careful. Hey, Fujin, are you doing it?
Yes.
Great. Okay, Devon, got your answer? One more time. Okay, now, okay, guys, I want you to be careful. If you use the formula as it is, make sure you key in the values correctly. Final velocity is 0. Initial is 10. Initial is over here, 10. Time, 1 minute. Make sure convert to 60 seconds. that will give you minus 0.166, right? Correct. 166 meter per second square. But sometimes your school is very, very particular because they ask for deceleration. So if they ask for deceleration, you reverse this sign, so it becomes positive. By right, you have to reverse the sign, by right. No, if they ask, no need. If they ask for acceleration, then yeah, the negative is there. But if they ask for deceleration, by right, now the negative is no longer there. You should, I don't know how fussy your school is about this. Okay, just one last example before I let you do some exercises.
Exercise? What exercise?
I will send to you very soon.
No! No!
Gang Fuching is good for you.
Meow.
Okay, same thing. I give you this graph. Okay, same thing. Speed time graph. So you see something like this. Okay, describe the motion. Yep, Devon, how would you want to describe it? No, same thing for you, Fuchin. Think about speed, think about acceleration or deceleration. These are the two common things to answer. So first thing, look at speed. Yeah, Devon, what? Good. Speed is decreasing. And in this case, I mean, I didn't draw really well, but basically it's decreasing to a constant speed. Okay, because you see this flat horizontal line here. How about acceleration, Devon? What can you say about that? Is increasing. Are you sure? Now, look at the gradient. Is it positive or negative gradient? Yep. So what does that mean? Like, yeah, okay. Yes, it's decelerating, but is deceleration increasing or decreasing? Look at the slope. What happened? What is happening to the slope? Here is very steep, right? Gentle, 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 zero slope. So deceleration is, the slope is getting gentle. Okay, so look at the slope. Steep means fast, or okay, let me rephrase. Steep means high deceleration or high acceleration. Okay, so in this case, it's getting gentle. So that means deceleration is decreasing until zero. Okay, so here gradient is zero, which you must be able to tell. So that means deceleration or acceleration is zero. Okay, so yeah, be able to look at the slope. You too, Fujin.
Okay.
Now let's give you one last example. Oh, and by the way, sometimes they use another term that you must recognize. Now, in this case, basically, basically deceleration is non-uniform. Okay, so make sure you're familiar with this term as well, non-uniform, because it's not constant. Last example, before you do your exercise, would you? Okay, so last one, I give you this graph. So same thing, speed time graph. Okay, Fujin, describe the movement.
Chaotic. Yeah. Joking. Okay.
Say again.
It's increasing.
Good.
Increasing at a constant speed.
Speed
not
is
constant, not constant. Because of that curve, right?
So acceleration.
Its acceleration is decelerating.
No, is it accelerating or decelerating? Be sure.
It's accelerating because it's going up.
Yes, good. It's a positive curve.
Accelerating gently.
Come look at the slope. Look at the slope. Come here is gentle, steeper, steeper, steeper. Very steep. Very, very, very steep. So, is acceleration increasing or decreasing? Increasing, okay.
Sorry, what?
Acceleration is increasing.
Yeah.
Because even though you don't have to write your answer, because slope is getting steeper. Make sure you can read that. Can they want? Okay. It's easier to think of slope as steep or gentle. Gentle means low deceleration, low acceleration. Steep means very high acceleration or deceleration. Okay, come, Devon, I pass this worksheet to you. Okay, try to do as many as you can. Uchi, I will send you the worksheet right now.
Okay.
Okay, Fujin, do as many as you can.
Okay. and
Any question? No? Okay. Fuji, any question? I assume no.
I legit don't understand kinematics. I don't understand a single thing.
Huh?
Like I don't. Okay, is there a way for me to annotate?
Is that for you to annotate?
Yeah, because I want to like. Okay, question 7.
7. Okay, why?
You see that from point 0 to point W, is that even
Hmm.
called an increase? And it's from point W to point X, the steepest point. Like so, there's more acceleration into it.
Okay, come. Let's look at it. Now, acceleration depends on slope. Okay, I think that one you all should have figured it out. So what? Fujin, tell me, where's the steepest part?
I would say it's from W to X.
Actually, at point W, that is the steepest if you use your
From
ruler.
point W to X, because from point W to X is increasing, right? No way.
No. Steepest is at point W, right? But at point X, wow, point X is like horizontal already,
point
no?
X is going like constant, no acceleration.
In fact, point X is zero slope, no?
Yeah, I know. But I mean,
Okay.
like from that, I mean, like in between point W and point X, that's like the steepest part.
But okay, you're right. However, think in terms of the slope. Is it becoming steeper or is it becoming gentle?
Wait, can you zoom in a bit? Because you see, after the middle point from point W, point X, right? It's
Yeah.
like curving. Like, how do I explain that curve? Is this an acceleration or what?
Is it acceleration? If as long as your curve is positive like this, it is acceleration. But if you see a negative slope like this, then it is deceleration. So it's still acceleration, right? Correct?
Yeah.
Because it's a positive slope. But the question is acceleration increasing or decreasing? In this case,
from point W is definitely an increase, but in the in between from that middle point of W to X, I'm not too sure already, because that curve is very rounded.
Yeah. But the point is the slope is getting less and less steep. And that translates to your acceleration decreasing. That's how you read the curve, because the slope is getting less steep. Can follow, Fujin?
Yeah.
Okay, so basically acceleration is decreasing.
Yeah, I think I slowly get it.
Yeah, you get the hang of it. Okay, so you have your answer already. Alright, so it's W to X in this case. Not easy, but you need to get a hang of it. Right, David, Ken? Alright, so make sure you get the answer. Answer is B. W to X. Of course, if any of you have any other question, yes, please voice out. Ivan, Fujin, any other question? No? Oh, really? That's good. Fujin, have you finished the MCQs?
Hold on.
That one okay with this one? Confusing. Okay, let's do an example for this. Yeah, Fujin, you can listen up too.
Okay.
So it travels at 15 meters per second for 2 minutes. 15 is here. So it's a constant speed. So that means you draw a straight horizontal line until 2 minutes. The next one is accelerating uniformly. That means this is a straight line. But you don't know what's the gradient though. So the tricky part for here is you have to use your formula. And as I said many times, there's only one formula to use. So you write out your formula. Oh, sorry. Okay, sorry. I retract my words. You do not need your formula because they told you the final speed. And they also tell you the time. So that means from this point, 0.5 minutes is where? Here. Okay, so this is 2.5 minutes. All right, so at 2.5 minutes, it reaches a speed of 30. So look for 30, 30 is here. Okay, 30 is here. Then you just join this point by 2 points by a straight line. Of course, I'm not using a ruler. You should be using a ruler in your test. Then it continues at uniform speed of 30 meters per second for the full 9 minutes. Further 9 minutes, I mean. Therefore, from here, 2.5 plus 9 minutes is 11.5. So there's no change in speed, just draw a straight horizontal line across until 11.5, which is here. Lastly, it decelerates. Okay, guys, decelerates means a negative slope like this. And to rest, guys, rest means speed equals to 0. Don't forget that. In 1.5 minutes. Speed 0 means x-axis. So 11.5 plus 1.5 minutes will give you 13 minutes. So this is the endpoint. But it's not uniform. Not uniform, meaning it's not a straight line. This is the tricky part. So it's actually a curve. Therefore, let me erase this part. You would expect it to be like this then. Okay. And then if you plot it on or sketch it on the graph, it should look something like this. Make sure there's a curve in it. It's not a straight line. So that is your final answer. Okay, can. Eugene, all right.
Yes.
Excellent. Okay, continue. Huh? Okay, if you look at 2A, they ask for acceleration. My best suggestion is start using the formula. It applies for 2B, Timon. Okay, 2A shouldn't be
I
a
hate
problem.
this.
Hmm?
I hate this. So hard.
So hard. This is as easy as it gets.
Huh? It's easy.
Okay, I would say these are standards. Timon, what do you get for A, by the way? 0.5, huh? Okay, actually I can't remember the answer, but let's work it out. You use your formula. All right, make sure your final velocity or final speed is 10, initial is 0. Oh, you're still doing question 1. Okay, then you carry on first. Question 1 is about distance, huh? All right, so make sure you use your area. I hope you remember that. Yeah. When it was traveling at 30 meters per second. Okay, same thing for you, Fuqin. If you have questions, do ask.
No, sir.
Okay, fantastic. Okay, Devon? Do you get your 2A, Devon? Okay, what do you get?
12.5.
12.5, huh? Okay. You say 12.5? Calculate again.
Oh,
Hmm?
When it's calculating. 1.25.
Yes, yes, that costs you your marks, huh? Please don't be careless. Yep, Fujin follow as well. Okay, for 2B, 2B is something that's not covered in your test, but perhaps in the later test. However, it is something I've mentioned. I've taught already. It's about force. And there's only one formula for force. This one. Try to remember that it's definitely coming up. So they ask for force. You know the mass of the athlete, or athlete in this case is 80 kg. Acceleration, you have already calculated from part A, so just substrate in. All right, so work out the answer using a calculator. Just don't be careless, that's all. And you should get your answer. What do you get? Good. Okay, 100 newtons. Now, part C. Part C is total distance. So what should you do, Devan?
I'm trying. The area is
Yes. All right, so well, it's not exactly a square, it's a rectangle, but you get the idea. All right, so for part C, please find out the triangle. Okay, this one, can you do yourself? Try, all right, basically the area. I think shouldn't be a problem, right, Devan? All right, yep, try to work it out. You too, Fujin.
Okay.
No problem, with the base and height. Should be okay, Okay, this one I won't work out for you. Work out the answer. All right, try it out. Oh, Devon, you get an answer? Yes, sir. Okay, what's the total distance? 100 meter. Okay, I can't remember the number. Let's take a look. Yep. Okay. Yeah. Fujin, I hope you're following. Make sure you get 100 meters. Huh? No, the other one is how about this one here?
Go toilet.
Yes, go
I go
ahead.
toilet. Okay.
I didn't ask you about this. What do you get for this, Devon? 0.5. And the distance?
Trouble.
Oh, a bit of trouble. Okay, come, let's interpret it. When it was traveling at 30 meters per second, look at the graph. Where is 30 meters per second? Yeah, that straight horizontal line, right? So therefore, I'm only interested in this area. Yes, it's just a rectangle. That's all, that's all. Yeah, it's not including the curve. It's only for that rectangle. Yep, good. Let me double check the 0.5. I think you're right. 0.5. 270. Oh, you didn't convert the minutes, huh? Okay, 0.5 is right, but you didn't convert minutes to seconds. Yeah, I missed that route too, so don't be careless. Okay. Fujin, are you back already? Okay, now. Devon, I tell you what, let's go to the MCQs because I really want to go through before your test. Fujin, are you back?
Yo.
Yes, let's go through the MCQs first.
Okay.
Number 1, heavy steel ball from a height of 2 meters. Fujin, what's your answer for number 1?
Let me see.
Yes, Fujin.
So okay, let's see. Steel ball falling from a height of 2 meters. Heavy steel ball.
Go on, Fujin, let me do something.
The first one.
Yes, your answer, Fujin.
First one.
Excellent. Make sure you get A. Okay, reason, come. I mentioned this before, but I just want to emphasize it because it's falling at gravitational acceleration, which is, please remember this number, 10 meters per second squared. Okay, so if you draw a speed time graph, it will be a straight line like this. Okay, let's go on. Okay, can Devon? Make sure don't get it wrong. Number 2, what is the best description of non-uniform acceleration, Devon? Non-uniform. When you free fall is constant, right? So increasing rate of change of, okay, right, should be C, yeah. Okay, that means your velocity is increasing, but the rate of its increase is also changing. So rate, oh, okay, guys, let's interpret this question. Look at this phrase. Rate of change of velocity is actually acceleration, no? And since they say it's increasing, yeah, that means acceleration is non-uniform. Can? Okay, so I mean, be careful when you read as well. Number 3. Okay, look at number 3, speed of weather balloon as it rises through. Which point does the acceleration start to decrease? Ah, Fuqin, you better know the answer.
These.
B for boy, ah?
No.
Yeah? What's your answer?
Acceleration start to decrease. C.
That means, yeah, sorry.
C.
Yes, excellent. All right, I hope both of you notice your slope is getting more and more gentle. Okay, that's when acceleration decreases. 4. Okay, move from rest. What is the average speed? Everyone? No. Okay, guys, this one is tricky. Yeah. Oh, actually, there's one formula that I missed out because it's a primary school formula. Day one, what's the average speed formula? Total. Yes. Did you use this formula?
Or no,
No, So calculate total distance, which is area under curve. So if you calculate correctly, half times base times height. And then divided by time, total time, you should get your answer, which is 6 meters per second. Okay. Okay, try not to forget this formula too, average speed, even though it's primary school formula. Got it, Fuqin?
Yeah.
Number 5. Boy on a skateboard. Which row describes his motion for each 5-second period? Fuqin?
I
Ah,
don't know. Can't be bothered to read.
yeah, that's awful. But anyway, answer? Yeah, number 5.
Ow.
No answer. Okay, I assume you don't know. They want your answer for 5? B for dog. B for boy. Okay, great. Okay, make sure you get this. This is a curve, so non-uniform acceleration. Horizontal line, constant speed. Straight line downwards, constant acceleration or constant deceleration. 0 on the x-axis means at rest, not moving. Okay, number 6, speed time graph for a car. Which one describes the motion? David? Oh, you don't know. Okay, come.
Hold
Let's
on.
look carefully. Yeah, Fujin. Look at this portion. Yeah, it seems quite flat. So in other words, it's at rest, no? Because the speed is 0. Then what happened to the curve here? Oh, the slope is increasing, 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 increasing. So I hope you can tell that means acceleration is increasing because slope is increasing. So in other words, acceleration is non-uniform because it's changing non-uniform. And finally, the last portion, I hope you can tell, is a straight line. And that tells you acceleration is constant or uniform. So by now, I hope you know your answer. Okay, the answer did not mention at rest, so the best option is A already. Okay, let's go on. Number 7, we've already done it. Number 8, at which point does the parachute open? Oh, this one is very tricky. This one, you make a guess? Skip.
Yeah.
Fujin, number 8, do you do it? Oh, yes, disappear.
Yeah.
Okay. Oh, I assume no then. Hey, come, the point is, this is important. Maybe on the neck down.
I'll
Parachute.
say it's point B.
Yes, you did. Okay, excellent, Fujin. Yeah. Okay, can that one. No need to explain, right? No need. Okay. This one, 60 minutes, 100 kilometers, 30 minutes, 20 kilometers. Oh, better get this right. Divan? Oh, okay, this one you have to know. Remember average speed? So, total distance over total time. Yeah, don't be careless and forget it. Okay, so if you work it out, you should get C as the answer. Okay, but anyway, you should know that formula too. Number 10. Okay, 40 kilometers, speeds up with constant acceleration for 3 minutes, reaching a final speed of 80 kilometers per hour. What is the distance? Wow. Fujin, do you try this, number 10?
Let me try now.
Oh, no, okay. How about you, Devon? Do you try that? Oh, no. Okay, guys, you have to try. My suggestion is you have to draw your own graph. It's not given to you, so sometimes you have to do it yourself. So at first it starts at 40. But take note of the units. They are not SI units. Speeds up with a constant acceleration for 3 minutes, reaching 80. Okay, you should have some sort of graph like that. All right. What's the distance traveled during this time? What time? There's only one time they tell you, and that is the 3 minutes. Okay, so it's this. Okay, so this area is what you are interested in. Should be able to complete now, right? I guess. The only difficult part is convert to SI units or convert. This one is a bit tricky because of the units. So let me do it for you. First thing, how? Triangle or what? What area should you use? It's actually a trapezium. Okay, now, so area equals to half times parallel sides times height. Okay, but the tricky part is this. Where is my height? This is my height, no? That is the tricky part. The reason is these are my parallel sides. Okay, so you have to interpret the question. So if I sub it in half times 40 plus 80 times height, but 40 and 80 are kilometers per hour, whereas this is 3 minutes. Convert minutes to hour, so it's 3/60 hour. That's the tricky part that you miss out. Sub in, punch your calculator, tell me the answer. Yes, good. All right, guys, you should get your final answer as 3. The only thing is be careful of the hours. Okay, I think that's about enough for today's practice. Bring this back next week. Any final questions for today? Eugene?
No.
Okay, great. Anyway, this session is recorded, so in case you want to rewatch it, I'll send you the link.
Okay.
Okay, guys, yeah, that's all. So, yes, see you next week.
Bye-bye.
Bye. Everyone, okay.